The environmental sustainability of AI software and hardware systems is still not very much debated today. On the one hand, digital technologies may represent an opportunity to achieve sustainable development. For example, the use of smart grids to better manage energy consumption. On the other hand, processing and elaborating large amounts of data and the disposal of digital devices have a strong impact from an environmental and a social point of view. At the core of the concept of sustainability lies the idea that the well-being of present and future generations, ecosystems and populations are interconnected on a global scale. Sustainable Development Goals have been set by the United Nations to achieve sustainability by 2030. The United Nations recognize that the digital revolution can have a key role in achieving Sustainable Development Goals. For example, the action for climate change can be supported by the use of satellite data to track deforestation. There is, however, the risk that available data are not representative of all groups, in particular of those with a difficult access to digital technologies. So in general, we can say that the relationship between sustainability and information society is ambivalent. It's not easy to evaluate the environmental impact of digital technologies in general and of AI in particular. Several elements of uncertainty are present. Digital and AI technologies present high levels of energy consumption. The metaphor of cloud, ethereal, without limits, that can be easily extended and where data can be always reached, can be misleading. This metaphor risks to hide that the cloud, to work, needs real industrial infrastructures that occupy physical spaces, alter urban and rural environments, consume energy, release greenhouse gases, and finally end their life cycle in trash dumps. The increasing use of cloud computing and internet-based services has a strong impact on the so-called carbon footprint. AI systems in particular require high level of energy consumption to train algorithms. For example, the training of a deep neural network for natural language processing emits a quantity of greenhouse gases that is almost 5 times larger than those of the entire life cycle of an automobile. This is not only a scientific and technical problem, but also, and perhaps mostly, an ethical and political one. To deal with digital pollution, we must consider both quantitative data and human values, such as the inequalities raised in the context or the responsibilities of the different stakeholders. Let's consider some of the values at stake in this context. A widespread approach is to evaluate costs and benefits of digital activities in order to maintain climate warming within acceptable limits. This approach is in line with consequentialism, that in this case takes into account wide consequences of the use of digital technologies in order to maximize the benefits. This means considering not only the environmental impact of digital technologies, but also their impact on education, health, and energy consumption. This approach presents several problems. First of all, costs and benefits are often calculated only in terms of monetary units, but some values cannot be expressed in these terms. Second, the impact of technology sometimes is difficult to be evaluated and expressed with measurable quantities. And finally, it is not easy to define what a benefit or a risk is. To reduce digital pollution, it is essential to know not only its entity in an absolute way, that is, the pollution produced by AI technologies, but also its entity in a relative way, that is, the level of pollution related to the environmental and social advantages. Moreover, also indirect effects have to be considered. For example, remote working from home could reduce the use of automobiles, but could increase energy consumption in private homes. These indirect effects are difficult to be evaluated. So to establish the sustainability of digital services, it is important to consider both the numerical value of their environmental impact and their social value, such as the way these services promote the access to education and health, or favor the advent of a society with less inequalities and discriminations. But social values are difficult to measure and cannot be determined in a uniform way. Their importance can be different according to different contexts and people. However, sustainability is an urgent problem, and decisions must be taken also under uncertainty and incomplete information. In this context, ethics is necessary in order to consider not only quantitative aspects, but also moral and social ones. Now, let's consider the problem of the just distribution of benefits and damages associated with the environmental impact of AI technologies. Data centers impact on natural resources that are limited, such as the lands where they are physically built, or the use of non-renewable energies to produce electricity. Moreover, the impact on some social and economic elements. The presence of huge data centers in the suburbs of some Scandinavian cities produce significant political and social changes in those areas. So, in general, it is important that the decisions related to the organization of the urban spaces are transparent and democratic. They must be subjected to public scrutiny and not only to the economic decisions of corporations, because they have an impact on a large number of people. Justice concerns also the disposal of digital devices. This disposal is often located in poor countries where regulations are sometimes not respected. For example, people working in highly polluted structures for disposal can suffer from serious health problems. These elements raise issues about the fair distribution of costs and benefits of the digital revolution. The high-level expert group on AI, nominated by the European Commission, lists environmental sustainability of AI as one of the criteria to be considered to achieve a trustworthy AI. As we have seen, measuring and implementing environmental sustainability is not trivial. Moreover, so far the goal of sustainability in this context is a voluntary matter, and this decreases its real impact. Different companies declare the goal to achieve carbon neutrality or better zero net energy standards, which are not only a compensation of carbon emissions, but also a reduction of them. However, these goals are often presented without clear information on how they must be implemented in practice. This is the reason why some of these initiatives are labeled as greenwashing. The goal is more to positively influence public opinion and not to promote a real positive change. In conclusion, improving digital pollution and increasing the sustainability of AI is a technological, ethical, and political issue, where the different values at stake have to be considered in order to set shared moral values for a wide governance project. The responsibility of each individual plays a very important role, together with those of the public bodies, both at the national and international level. However, as we have seen, it is essential to analyze this issue with a global perspective that moves beyond the idea that technological progress can fully solve this problem, for example, only by improving the energy consumption of AI systems.